Hi everyone. Today I'm going to talk about section 2.4 Math 180 Business Calculus. This section I'm going to talk about the chain rule and general power rule, and we're going to answer the question: how do we take the derivative of a composition of functions? If you remember, that's the composition of functions, something like f of g of x, something like that, right? And we are taking derivative of that. Say this should be around in this area, better. Okay, so the only way to do derivative of our composition of functions will be a chain rule. Okay, so what is chain rule? Chain rule is when you see that a function of hx is a combination between f and gx here, you will get the derivative of hx will be equal to f derivative of gx multiplied with the z derivative of x. So what does that mean? F derivative of gx is the outside derivative, or as I'm gonna say the derivative of outside function. Should I just gonna using so outside derivative of derivative of outside function, and then multiplied with the derivative of the inside function. Maybe I have to put down this equal. Okay. So maybe around here. All right. So that is chain rule. And in order to use chain rule, you usually gonna let something like a letter like use to be the inside function. Okay, so let's do an example. I have example 3 here, and I want to find the derivative of each following function. Say problem A, I have y equal to 4x cubed plus 5x plus 2 to the power 6. So I would like to have a side work, and I say let use equal to the inside function. What is inside function here? It's 4x cubed plus 5x and then plus 2, right? Only the inside of the inside function. I don't want to put the power 6 here, okay? Now I'm gonna say, oh, so I would like to find the derivative of inside function, all right? So it's gonna be u prime. I would like to take the view of this. We give me 4 times, so 3 put down, 4 times 3 is gonna be 12 x square and plus with 5. All right. So that is the u primes. What about I want to find the outside derivative? Okay. So how can I do that? I know that now y can be rewrite as use to power 6 better. Okay. Maybe I'm gonna write like this because use is equal to the 4x cubed plus 5x plus 2. So if I write u as a function with respect to use, then I have use power 6. Okay, so I will have y derivative with respect to use, which is outside derivative of outside function. Okay, so with equal to let me rewrite as derivative of outside function. y derivative of u's will be equal to what? It's gonna put down 6 and then multiply by u's power 5 because 6 minus 1 equal to 5. Okay, so that is the that is a derivative of outside function. Now I would like to to find the derivative of y with respect to x by using the chain rule. I know that I need to take the derivative of outside function, okay, multiplied by the derivative of inside function, right? So I'm gonna copy this down, equal to this, okay, make it not bold. Okay, so now I would like to substitute things. I have the derivative of outside function is 6. I'm gonna make it color is say blue. Oh, this one is not really is nice. So change it to be this one. Not nice too. Okay, so I'm gonna change it to be red like this. Okay, so 6 use power 5. So I'm gonna put down 6. Okay, and use. What is use? U is inside function, which is 4x cubed plus 5x plus 2. Okay, so I'm gonna put down. I'm gonna change use right away. Okay, become the inside function. So it's 5 over 5. And also I need to multiply with the derivative of inside function. Okay, so multiply by the derivative of inside function was here, was 12 was 12x power 2 plus 5. Okay, so that is the way to do to use chain rule for take derivative of composition function. Now I want to move to B. Okay, maybe use this B. In B, I have let me write fx equal to 4 over 6 minus 2x over 5. Okay. This could be rewrite as a composition function. So I would like to let use become the inside function in here. What is that going to be? 6 minus 2x. Okay. And then I would like to find the derivative of inside function, which is u prime. And in here is right away give you -2. 6 becomes 0, right? So now you have u prime already, which is an inside derivative inside function. You need to find the outside derivative, right? Move out the C. You have f derivative of u's. No, actually, I'm gonna rewrite fx will be f of u's, right? Which is 4 over u's to power 5, right? And I can even rewrite it become like a power rule, because in here you see that a constant on the top, bottom is like a just a variable, look like only a variable use. So I would like to change it become power rule, which is 4 times u to power -5, right? So now I would like to take the derivative of outside function. So I'm gonna have 4 times -5 to power times u to the power negative 6. And simplify, gonna have negative 20 times u to the power negative 6. And I would like to circle it. Now, since I have oh, what happened? Since I have outside function already. Since I have outside function already, derivative outside function already, derivative inside function already. So I would like to apply into f derivative of x. Which gonna give me here's let me write as derivative of outside, and then here's derivative of inside. Okay, so I'm gonna keep using derivative of outside multiply with derivative of inside. So outside is negative of 20 u's. Now I change u to be a function of x. So u's is 6 minus 2x. You know that from here. So you're gonna multiply by the inside function, which is the derivative of inside function, which is negative 2. And you're gonna combine it or simplify it. You're gonna get 40 times 6 minus 2x. Or if you do distribution, you will get what? 40 times 6 gonna be 240 minus 80x. And that should be the answer of this derivative. Did I miss anything? Let me see. I think I missed negative. Oh yes, that's why I cannot have this answer. I missed a negative of 6 here, so I should have negative 6 here. Okay, so I should have this as the answer better. So 40 times 6 minus 2x to the power negative 6. Okay, so if you want to change it to be the positive power, you can make it become like 40 over 6 minus 2x, and then to the power 6 here. So these both should be okay. I'm not sure in the expression work, but I think they should accept both this answer. For C, what is C? C is y equal to square root, cube root, fifth root of 7x minus 8 cube. Okay, so this one may be a trouble with you, and it should appear on your assignment or maybe homework later. So let me see. So 7x minus 8 cube. 7x minus 8 cube. Okay, so in this case, you should know that which one is what is that? I have y, right? Y equals this. Which one in here is inside function? Inside function should be 7x minus 8. Okay, so I would like to have u equal to 7x minus 8. And then I'm gonna have u prime will be 7 only. Okay, so come back with the y here. I could change it to be y, a function of u's, function y that affects u's in here, and could be right as fifth root of u to the power third. Okay, and if you see like this, it looks like a crazy function. So you want to think about changing it to be power function. And as you learn in correct algebra, the index of the root will be the denominator of the power. So I'm gonna have u to power 3/5. Okay. So remember the index with fifth root in here, the fifth one here, the number 5 here, gonna be the denominator of the power. Okay, so now I have the y I expect to use. I would like to take the derivative of outside function here. So I have y derivative of use will be equal to 3/5. I put out 3/5 here. I multiply with use, and then I'm gonna have 3/5 minus 1. Okay, so in the case that you have like a fraction power, I would like to slow down and then do do all the steps for the power rule. So in here I have 3/5 stay, and use now gonna have if you want to do a side work for 3/5 minus 1, you should know that it's going to be equal to 3/5 minus 5/5, right? And then 3 minus 5/5 going to be equal to -2/5. So now the top going to be -2/5. Okay, so if you want to change it back to be a positive power, you will have to have 3/5 times with 1/u to power 2/5, right? And now you can combine it to be 3/5 times u to power 2/5. And if you want to change the fraction power to be radical, you can change it as 3/5 times fifth root. Okay, remember the denominator of power going to be the index of the root, and multiply with use to power 2. Okay, because why the numerator going to be the power of the radical. Okay, so now I am having outside derivative with this guy, or you can even stop here to me. Okay, if you don't like to rewrite this as a positive power and all the radical, so you can just stop there. I believe that XYZ still accept that. So I'm gonna take this as the outside function for now. I would like to change the color and then use this as the u derivative of 7. U derivative equal to 7. So now I'm gonna have the derivative of y with respect to x going to be equal to so outside derivative going to be 3/5 times u to power -2/5, right? But in here, u is equal to 7x minus 8. All right, I gotta change this. Okay. And I multiply with the inside derivative, which is u prime, and then this is 7. And now time to simplify. I will guess y prime x will be equal to 21 over 5 times 7x minus 8 to the power negative 2 over 5. And I would like to say like stop here, even though that's the power is negative and a fraction, but I just want to stop here. All right. Yeah, that should be the answer for problem C. That's it. So now I'm gonna try to explain more for you in example 4. Okay, so let's see. In example 4, I give you the answer here already. You can try. If you want to try before looking at my solution, you can try, pause my video and do it. So now I'm gonna show you the solutions. So first thing you need to know that f of x equal to 2x minus 1 over 4, 3x plus 2. Okay, this is a little bit crazy, function because why? You are not having only one, only I mean like you are combining between quotient rule and chain rule. So you don't have you use only chain rule here. You cannot handle this. You have to apply quotient rule and chain rule in this case. So quotient, look globally. You notice that this should be like a quotient rule. Okay, right? It should be look like and use over V here, right? So I would love to say this is the derivative of fx will be equal to v times u prime minus u times v prime over v square. Okay, so you need to have a big side work. Let me make it down a little bit. Uh-oh. Uh-oh. Okay, so you need to have u equal to what? 2x minus 1 to the power 4. And you have v equal to 3x plus 2. Okay, the thing in here is we are looking for the u prime, and we are also looking for the v prime. U and v we know already. V prime going to be piece of cake by taking the v in here. It's going to be equal to 3. But for the u prime, it's going to be problems, right? So you see that u prime, you see that u prime now is having like a composition function. So I would like to say you need to have one more time substitute. Say let because I have u already. I'm gonna let say g's equal to 2x minus 1, which is inside function, right? So I have g equals that, so then z prime will be equal to 2, right? So now I need to rewrite use a function of g's, which is g to the power 4, right? And then you can derive, rewrite is I mean, you can find the outside derivative gonna be equal to u derivative of g equal to 4g to the power third. Okay. Now it's time to find the u derivative which equal to the outside function multiplied with the inside function. What is outside function? Outside function is this guy, and inside function, what is that? Inside function is this guy. So I would like to write it as so outside function is 4 times g to the power third. What is g in here? 2x minus 1. Okay, and multiply with g prime is 2. Okay, so let me just make sure you still remember that outside function is 4 times z to the power third, and inside function derivative inside is 2. So now I'm gonna have what I need to maybe I need to move this down. Okay, and I need to combine or I need to simplify the u prime. What is that going to be? U prime equal to what? 8 times 2x minus 1 to the power third. Okay, so let's apply this. I have f prime x will be equal to v, which is what? V is 3. Don't forget the parenthesis. 3x plus 2. I think I need more space. So I need to say f prime of x will be equal to what? V is 3x plus 2 times u prime, which is 8 times 2x minus 1 cubed. Because this is all factor, so I don't need to have parentheses, but you put parentheses, that's fine. Minus for the u's, what's u's? U is 2x minus 1 to the power 4. And multiply v prime is 3. Okay, so you will have divided by v squared. So 3x plus 2 squared. And as you see, if you want to make it more neatly, the answer should be 8 times 3x plus 2 times 2x minus 1 to the power 3 minus 3 times 2x minus 1 power 4 over 3x plus 2 square. And I would like to say, can we do anything else for this? No, you cannot. Yes, so this will be the answer. So okay. Another example in here is example 5, and this also like a combined rule between product rule and chain rule, right? So so you see that in here I have look globally. I have a product between x fifth and 4x minus 1 power 1 4. So I can rewrite as fx will be equal to u times v. Okay, and if I take the derivative of that, I'm gonna have u prime times v plus v prime times u. And now I'm gonna have the assigned work. We use equal to x power 5, and v will be equal to 4x minus 1 power 1 4. Okay. And for the u, if I want to take the value of that, easily it's going to be 5x power 4, right? But for the v, if you want to take the value of that, that's going to be big deal if you don't use chain rule. So in this case, you still have to let the inside function become a letter, say g equal to 4x minus 1. That is inside function. So you know that is inside function. Now I I would like to find z derivative, which is a derivative inside function that equal to 4, right? So I have let me see. Now I would like to take the derivative of outside function, but before doing that, I need to change it to become a function of g. So that equal to g to the power 1 4. So now I have what that I'm gonna have v derivative of g will be equal to 1 4 g to the power 1 4 minus 1. Okay, I need to move this down. So v of g will be equal to 1 4 g to the power 1 4 minus 1 equal to negative 3 4. And then you're gonna have what you're gonna have v derivative of x. Now you're gonna have v derivative with equal to the outside derivative, which is 1 4 times z. What is g in here? G is 4x minus 1, negative 3 4 times that with the inside derivative 4 here, right? So let me using another color to color this. So this should be 2, and another one maybe this guy gonna be yellow. This one. So now I have I will have what's that? I will have f derivative of x will be equal to u prime times v. What is u prime? U prime was here. Let me change the color. Here. And v prime is this. Oh, actually, I can simplify more. So I have this v prime will be equal to, maybe I need to put out this. v prime gonna be equal to 4x minus 1 to the power negative 3, 4. Because this 4 cancel with this 4. So this should be the v prime. Okay, now for f derivative of x, now I can substitute v prime become 5x4 multiplied with v is what's the v? V is 4x minus 1 to the power 1, 4 plus with v prime is 4x minus 1 to the power negative 3, 4. And then time with and then I'm gonna time with the use. What is the use? Is x fifth. Okay, now it's time to combine things. Let me see. So I have f derivative of x will be equal to 5x. Oh, okay. I noted that. Oh, this one is this one. In order to do this one, you need you know that there is a common factor between to this big term, but you need to factor out. You need to factor out the term that have lowest power. Okay, you need to factor out the term with the lowest power. So I'm gonna say factor the term, the common term, common factor that have lowest power. Okay, so compare between two this factor. I have 4x minus 1 to the power 1, 4 and 4x minus 1 to the power negative 4, 3. I know that negative 4, 3 is less than 1, 4. So I would like to factor out, I would like to factor out 4x minus 1 to the power negative 3, 4. And then inside of the first term will be 5x4 times 4x minus 1. Okay, now watch out. You are trying to take away a factor with 4x minus 1 to the power negative 3, 4. That means what? That means you are taking 1, 4 here and then subtract for the negative 3, 4. And then you need to add with the second term did take away the whole 4x minus 1 to the power negative 4, 3, 4. So you're gonna just have only x fifth here. If you see that, right? Okay. So now you have f derivative of x will be equal to 4x minus 1. You know what? I'm gonna change this to be positive power. So 1 over 4x minus 1 to the power 3, 4 time with 5x power 4 multiply with 4x minus 1. Now 1 4 minus for the negative 3 4, which is plus 3 4. So I'm gonna have 4 over 4, which is equal to 1. Does that make sense? Okay, 1 4 plus 3 4 is 4 4, which is equal to 1, and then plus with x power 5. Okay, almost one more step. Okay, so f divided by x now can become 5. No, I'm gonna factor again. I'm gonna keep factoring the x4. Actually, you know what? I can even factor out here. Okay, I factor it one more time. Oh my God, it should be x4 here. So let me see how can I do. Okay, let me gonna clean this up, and I'm gonna rewrite as 4x minus 1 to the power 1 4 times x to the power 4, because I forgot one small thing, that we also have the x as the common factor between this term, and I'm taking out the lowest power. So in here is should be x4. So I'm taking out x4 here. Now I'm gonna have 5 times with the 4x minus 1 power 1 4 minus for the negative of 3 4, sorry, and plus with x only. See, I did factor out 4x minus 1 negative 3 4, and also factor out x to the power 4, and now I'm gonna just have only x. All right, so now I should not have x fifth here. I should have only x. I should not have x here. Okay, I'm gonna change it, become 1. Okay, now I can combine this and also have this as the x4 here. Okay, now I can multiply everything and have x4. Maybe I'm gonna have x to the power 4 multiplied by 5 times 4 is 20x minus 5. I am doing distribution for this one, and then plus x over 4x minus 1 to the power 3 4. And finally, I will get x4 times 21 x minus 5 over 4x minus 1 to the power 3 4. So this one is kind of like a little bit crazy problems, but I mean, in order to handle this problem, there's only one way to do this, and especially in the simplified step, you need to watch out with factoring stuff. So try to change the number and redo this problem, or you can redo this problem without looking back my help. But I'm pretty sure it's going to be one. There's going to be one problem in your XYZ homework. Okay. So now I would like to so there is only one more example, example 6 here. I would like to finish this. Okay. So for this example, when you look globally, okay, you see that there is a function with the power, right? So you right away need to apply chain rule for this one, okay? Or I mean, need to apply power power rule in this one. But this one combined between power rule and chain rule, and later on maybe even a quotient rule. Okay, so what happened? So for this one, I would like to say this one can be rewrite as f of maybe I gotta just say let u equal to 2x plus 5 over 8x plus 7, which is inside function, right? So I now changing it become f of u, which is u to the power 4. Okay, so maybe I need to have more space for this. So now in order to find the inside derivative, I need to have I need to substitute this, become a quotient rule is say f and q. No, I change the letter. I should say v and w, right? So in order to take the u derivative or the inside derivative, right? I need to have v no w times v prime minus for the vw prime divided by w squared. Okay, so in this case, you can do a side work. V prime should be 2 because the top of this is 2x plus 5. We take that is 2, and w prime will be equal to 8. Okay. So when you substitute in, you're gonna have u prime now equal to w is 8x plus 7 multiplied by v prime is 2, and minus for the v is 2x plus 5 multiplied by w prime is 8 divided by w squared, 8x plus 7 squared. And now I actually having let me see, how is there anything that I can do? No. Now I actually can say this is the inside derivative, right? So inside function derivative. And now I would like to take the outside derivative. Okay, so which is f derivative of u, which is equal to 4 times u to the power third. And I would like to color this as this one and say this is outside derivative. And now I would like to have f derivative of x will be equal to outside derivative times inside derivative. So outside derivative gonna be 4 times u to power third. What is use? Use is I need to color this. Maybe gonna be this guy. Okay, so this gonna rewrite as 2x plus 5 over 8x plus 7 to power third, and then multiplied by inside derivative. So I have a big one, 8x plus 7 times 2. I should combine that before move to here. But let's see. Okay, so I should combine that better. So I can rewrite this as u prime equal to, oh, can I combine this? No, I can't combine. No. Maybe I can still combine it by do distribution. Okay, yes, I should do that first. So, sorry, let me move down and then do e prime equal to, so 8 times 2 is 16x plus 14 minus 2x times 8 is 16x minus 8 times 5 is negative 40. So over 8x plus 7 square. And now I can cancel this and this. And I will have u prime equal to, what is that? Positive 14 minus 40, you're gonna give me 26 over 8x plus 7 square. So this actually gonna be the oh wait, is this actually gonna be the inside derivative? Inside derivative. Okay, so now in order to find the derivative of fx, it's going to be outside derivative multiplied with the inside derivative. So outside derivative is equal to 4 times with the use to power third. What is use? U is 2x plus 5 times 8x plus 7, and then multiply with the inside derivative, which is 26 times 8x plus 7 to power 2. Okay, if you must have power 3. If you want to combine this, so you need to know that 26 multiplied by 4, what is that equal to? Should be 104, okay. 104, and then multiply with 2x plus 5 to power third divided by 8x plus 7. Now I can even combine 8x plus 7 power 3 multiplied with 8x plus 7 to power 5. So then this should be the answer. And I'm missing a negative number. Where that? Oh, should be negative here. Yes. Negative here. And then negative here and negative here. All right. So I have finished section 2.4 today. If you have any question, please join my live class. Also, try to do assignment 2.4, and you're gonna have quiz that include 2.3 and 2.4 on the summer on the Sunday, and that's it. I'm gonna see you next week. Have a good weekend. Bye.